Hello guys, welcome back to the second part of applications of triangles. So in this video, we are going to discuss problems or applications involving law of sines. So let's begin. Let's have example number 1. So we have this problem here. You are on a hill and can see two buildings in the distance. Suppose the buildings are 6 miles apart. If you are 3.2 miles from one building and the angle between the two lines of sight to the buildings is 30.5 degrees, how far are you from the second building? Okay, so let's try to solve. So again, we will draw. It was stated in the problem that there are two buildings. So let's just try building A here. Okay, so this is building A, and let's have building B here. Okay, and they are 6 miles apart. Okay, so they are 6 miles apart. 6 miles. So if you are 3.2 miles from one building, okay, so let's say that the first building is A, so this is 3.2 here. Okay, let's try to erase a little bit, it's longer than 3. Okay, 3.2, so let's say this is 3.2. okay, and there is an angle between the two line of sights. So if we have another distance here and the angle here, so let's say this is angle C, ABC. So angle C is 30.5 degrees. So how far are you from the second building? So we are asked to find this side here. Okay, and this side here is our side A. Okay, so if it's using law of sines, of course, it's not indicated in the problem that this is a right triangle. There is no indication, there are no elements that stating that the triangle is a right triangle. So for sure this is an oblique triangle. Okay, so hence we will list down the elements first. So for A, it's unknown. For B, it's also unknown. For C, it's 30.5 degrees. Okay, for small letter A, we have unknown. So we're actually looking for A. Then we have B. B is this 3.2. And our C is actually 6 miles here. Okay, so obviously we are going to use law of sines because we have a pairing of an angle and a side. Okay, so we are again looking for A, but for us to look A, we need angle A. Hence, we need to solve first for angle B for us to solve for angle A, and then we can now solve for side A. Okay, so solving for B, we have sine B over B equals sine C over C. Using substitution, this will give us sine B over 3.2 equals sine of 30.5 degrees over 6. Then cross multiply, so we have sine B equals 3.2 sine of 30.5 it's not, it cannot be written, 3.5 degrees all over 6. Okay, then what is 3.2 sine 30.5 over 6? 3.2 sine of 30.5 over 6. This will give us 0.27 something. Okay, then getting the angle, so we just need to arc. Okay, get the arc of this one. Okay, so we have the inverse sine of this one. So we have 3.2 sine of 30.5 degrees over 6. Okay, so arc sine of 3.2 sine of 30.5 divided by 6. 0.2 sine of 30.5 divided by 6. Okay, so the answer is, our B is actually 15.71 degrees. Okay, next we'll answer for angle A. So how do we solve for angle A? So angle A is simply, just move forward. Angle A is simply the difference. To find what A, we have 180 minus 30.5 minus 15.71. So A is 180 minus 30.5 minus 15.71. So we have 134.79 degrees. Okay, so this is 134.79 degrees. So we have now the necessary elements to find the missing side. Again, we're trying to solve for A. Okay, and to solve for A, we will use law of sines again, since we have the pairing. So A over sine A equals, so we're going to use still C because this is the given. So we have C over sine C. Then we substitute, so we have A, sine A is 134.79 degrees, okay, equals C over sine of 30.5 degrees. Okay, then cross multiply, this will give us A equals, sorry, what is C? C is 6. C is 6. Okay, so A equals 6 sine of 134.79 degrees all over sine of 30.5 degrees. Okay, so using your calculator, we will have 6 sine of 134.79 divided by sine of 30.5. This will give us 8.39. Okay, and of course the unit, which is miles. So this is the final answer. So our answer is, I'll just write it here. Answer is, the distance is 8.39 miles. Final answer.